Welcome back to Clockwise Learning. In this short video, we will explore the digital alphabets and language used by our devices to send and receive messages. Just as learning letters is the foundation of understanding any language, these basics form the building blocks of digital communication today. What you're seeing are 4 essential steps a computer takes to deliver your message when you type a message and hit send. For all our early learners and anyone curious about this process, we think these 4 steps help you understand what happens when you type a message and hit send using any digital device. Please take a closer look at the details of the 4 basic steps. Please pause and read for better clarity. In the early days of digital communication, devices used ASCII to convert letters into numbers. While ASCII was groundbreaking, it was limited to just 128 characters, which worked for English but fell short for other languages. As global connectivity grew, the need for a more inclusive system became clear. Enter Unicode, a revolutionary standard that can represent over 1 million characters from nearly every language, as well as symbols and emojis. This advancement allows seamless communication across cultures, ensuring that no matter what language you use, your device can understand and transmit and receive it. To illustrate this process, we have selected 8 simple English words. And you are seeing how your digital device converts them into a format it can process and send, bridging the gap between human language and machine understanding. We have used ASCII for this representation just for simplicity. So far in our discussion, we have examined the fundamental concepts of ASCII, Unicode, and binary encoding. These systems are essential for translating our everyday language into a format suitable for digital transmission. To illustrate this process, we selected 8 simple English words and demonstrated their representations in ASCII format. Please rewind and revisit. In step 2, we then convert these ASCII codes into binary, the true digital language of computers. This approach allows us to show how each word that we type is initially represented in ASCII format and then is transformed into its binary equivalent, providing a clear visualization of the transition from human readable text to machine processable data. In step 3, the message is converted into a string of binary code. To illustrate this, let's take the word morning as an example. What you see here is how each letter in the word is represented in binary code using only ones and zeros. This process involves converting each letter to its corresponding ASCII code, which is then translated into binary. In the following 5 examples, we will demonstrate how any typed message is transformed into a long sequence of ones and zeros, which is the true language of the computer and is called the binary code. This is the fundamental process by which digital devices convert human text into machine language for transmission. We hope you now have a clear understanding of the 4 basic steps involved in transmitting and receiving text using any digital device. Remember, every message you send goes through this fascinating process. The message transforms itself into ones and zeros. The binary code gets compressed and encrypted for security and is organized into packets. These packets are then converted into radio waves for transmission. Stay tuned for part 2. We'll go deeper into even more exciting ways technology connects us.